f average on the interval, let's say a comma b. This is just a formula. 1 over b minus a multiplied by the definite integral from a to b from f of x dx. Very simple formula. It's the definite integral with a ratio in front. 1 divided by b minus a. So let's choose a couple of examples. I'll let you choose. They are on page 426. Four 26. Here they are. Find the average value of the function on the given interval. Anything you want, 34 through 44. Anyone?
43.
Yes. Let's start with 43. In 43, we have y equals 3 over x squared. And you know that this has to be changed immediately into 3x to negative 2. And the interval is 1 comma 5. So they're given us a function, 3 times x to negative 2. And they're asking us to find the f average on the given interval 1 comma 5. I have to have 1 divided by 5 minus 1, which is 4, times the definite integral from 1 to 5 from the original function, of course dx. That's the formula. We only plugged it in. Of course, I take 3 outside. So this is 3/4. And I have x to negative 2. I have to increase the power by 1, divide by that number, and evaluate from 1 to 5. It's a definite integral. This function is defined for sure between 1 and 5. It's not defined at 0, but 0 is not in the interval. So I can apply the fundamental theorem of calculus. So how do I proceed? Well, take these outside, like negative 3/4. Plug in 5, which is 1/5 minus 1. So now I have to go back to 1 over x. So 5 plugged in 1 over x is 1 over 5. And when I plug in 1, I get 1. I have to continue. I have negative 3/4 outside. And this is negative 4/5 times negative 4/5. I get a positive number. I simplify, and I get 3/5. So the average value of this function on the interval 1 comma 5 is 3/5 or 0.6. Now, again, what does this mean? So let's suppose we have a function, just an example for you. So let's suppose I have a function which is temperature. And let's say this function, temperature of today. So let's suppose you're asking me, what is the average temperature between 1 p.m. and 5 p.m.? What should I do? I will find 1 over 5 minus 1, the integral from 1 to 5, from f of x dx. And I will give you the average temperature that we had today, but you have to give me the function. If you give me the temperature function, and you say find the average of the temperature that was today between 1 and 5, I will give it to you. I will find, I put a ratio of 1/4 in front, then the definite integral from 1 to 5, from the function you give me, and I'll tell you what the average temperature was between 1 and 5 today, as an example. Okay? see if we want to work on another example of finding the average value. If not, I will go back to the previous page.
We do know we're at 38.
Yes, of course. Let's look at 38. Good. In 38, we have f of x equals x squared plus x minus 2 on the interval 0, 4. Is this the one? 38? Did I hear correctly?
Yeah, yep, 38. X squared minus x plus 1.
Perfect. Good. So f average on the interval 0, 4 is 1 over 4 minus 0, which is 4, the integral from 0 to 4, from the original function dx. That's all we need to do. And of course, we find the antiderivative. This is a continuous function on this interval. It's polynomial. X to the third over 3 plus x squared over 2 minus 2x from 0 to 4. Luckily, it's a polynomial. When I plug in 0, everything is 0. I only need to plug in 4. So I have 1/4 outside, 4 to the third over 3 plus 4 squared is 16 divided by 2 is 8, minus 8, luckily these go away. When I simplify 4 with 4, I get 16 divided by 3. So 4 to the third over 4 will be 4 squared. 4 squared is 16 divided by 3. Are we okay with the formula of the average value of a function on a given interval? Is that a yes? Is that a no? Anybody?
Yep.
Okay. Now I would like to go back to the book and go back one page. Here it is. There are two sets of situations here. Find the area under the graph of a piecewise defined function. You thought you got away with piecewise defined functions, or we can forget about them. No, we cannot. So this is one situation that I would like to discuss. The second one is we are already given the graph and the functions, and we are asked to find the area shaded in. Okay. Here's the third type. Actually, there are three. Here's the third one, in which we don't have the graph, we have to graph, we have to find the area, we have to shade it in, and then calculate it. So let's start slowly, meaning from 1 through 6. And I'll explain what we need to do. So we are given piecewise defined functions, and we're asked to find the area under their graphs. Anyone would like to choose one? Or I will. Okay, I'll choose 3. So we have g of x equals negative x squared plus 5 for x less than or equal to 0, and x plus 5 for x greater than 0. And they're asking us to find the area for 3 and 4, so for 3, between negative 2 and 3. We don't really have to graph this function. It would be nice, but there is no need. Notice one thing, that whatever the graph looks like between negative 2 and 3, there is a break at 0. Meaning, on this side of 0, I have a function. On this side of 0, I have a different function. So between these two, between negative 2 and 0, I have to integrate using this function. And between 0 and 3, I have to integrate using this function. It doesn't matter how the function looks like. So the integral from -2 to 3 from g of x dx, and we are going to use, I'm just going back, we are going to use this property. In our example, we have from -2 to 3, from this function dx plus from 0 to 3 from this function dx. So the integral from -2 to 0 dx plus the integral from 0 to 3 dx. And these are different functions. Why? Because between -2 and 0, I have this function. And between to the right of 0, from 0 to 3, I'll have this function. And this is all based on the property of definite integrals that states that I can split the integral as many pieces as I need to. So therefore, the integral from -2 to 3 from g of x dx is the integral from -2 to 0 from the corresponding function that exists to the left of 0 plus the corresponding function that exists to the right of 0. And that's it. Polynomial functions, a fundamental theorem of calculus applies. So -x to the third divided by 3 plus 5x. This one is between -2 and 0 plus x squared over 2 plus 5x from 0 to 3. So I have to determine these two integrals, add them up, and that will be the integral from -2 to 3 from g of x dx. And the situation happens because this is a piecewise defined function. It has different functions on different pieces of x. Any questions before we calculate the two integrals? Any questions? Is it okay? Okay, so let's continue. So from here, so when I plug in 0, everything is 0, but don't forget minus when I plug in -2. So this is -8 with minus in front, so it's 8/3 and minus 10 plus. Now luckily I only have to plug in 3, which is 9/2 plus 15, minus when I plug in 0 is 0. So -8/3 plus 10 plus 9/2 plus 15. The least common denominator is 6. And this is 25. So this needs a 2, -16 and plus 27. So what do we have? So 11/6 plus 25. Okay, so 11 plus, this is 150 over 6. And this is 161 over 6. So the area under the graph of this piecewise defined function between -2 and 3 is 161 divided by 6. Any questions on this problem? Do you think we need to look at another? Or can we move
Can we
on?
get one more? Like,
Yes, of course, absolutely.
5 maybe?
Which one? 5? Very good.
Yeah, 5.
Okay, in 5 we have f of x, which is negative x minus 1 less than negative 1, and negative x squared plus 4x plus 5 for x greater or equal to negative 1. And they're giving us negative 6 to 4 this time. Okay. So in order to determine the integral from negative 6 to 4 from f of x dx, we realize that we have to add two integrals. Can anyone help just get us started? The integral from what to what?
Is it negative 6 to 0?
Negative 6 to negative 1 this time. The split is at negative 1, not at 0.
Yes, sorry.
Perfect. Plus. Very good. Plus.
The other one's negative 1 to 4.
Very good. The first one is from what dx, and the second one is from what dx.
Would the first one be negative x minus 1?
Of course. And the other one from negative 1 to 4. So negative x squared plus 4x plus 5. I'm going to write it again because it's not clear. I didn't have enough room. So the integral from negative x minus 1 dx from negative 6 to negative 1 plus the integral from negative 1 to 4 negative x squared plus 4x plus 5 dx. You don't have to write it twice. I had to because it was squeezed in there. Okay, perfect. So now we have to calculate two integrals. Negative x squared over 2 minus x from negative 6 to negative 1. Plus negative x to the third divided by 3 plus 4x squared over 2 plus 5x from negative 1 to 4. Ugly, very. So I'm going to plug in those numbers and we can determine them with the calculator because it will take me 5 minutes to calculate all the arithmetic. So when I plug in negative 1, I have negative 1/2, and this is plus 1. Minus, when I plug in negative 6, negative 36 over 2 plus 6. And now plus, I plug in 4, negative 64 over 3. Plus 16, plus 32, plus 20. Minus, when I plug in negative 1, 1/3 plus 2 minus 5. It will take me a few minutes to calculate all this. You can use the calculator. Or you can just finish it up later. I'm not lazy, I just don't want to waste time on arithmetic and adding fractions. Unless you want me to. It's up to you. You tell me. You decide.
I don't mind if it takes a few extra minutes.
Yes, perfect. Okay, so negative 1/2 plus 1. This is negative 18 with minus in front, and this is minus 6. Minus 64 over 3, and then is 52. Minus 1/3, and this is negative 3, so plus 3. Okay, let's see what I have here. 52 plus 18 is 70. 74. 68. minus 1/2. Here I have negative 65 over 3. Okay, so the least common denominator is 6. So I have 6, 3, and 2. 36, 40. Yes. Minus 3 minus 130. So 408 minus 133. So I have 5. I have 7, 2. Can I simplify this? No, I cannot. Good. Let's continue. I want to look at these areas. Find the area, but I have to explain what happens here. So, you remember a few minutes ago, we looked at something like this. And they were giving us A and A. And I was asking, what do you think those results are, and so on and so forth. Well, if we have an area that is enclosed, I'm going to use 2 different colors so you understand what I'm saying. Let's say this is f of x. And let's say this is g of x. And we are asked to determine this area. And we have the limits. Let's say between -3 and 12. This intersection points. One is at -3, the other one is at 12. How do I determine this area? The enclosed area. This will be definitely the integral from -3 to 12. From the upper minus lower dx. What do I mean by upper? It's the function that is above. So the integral from -3 to 12 from f of x minus g of x dx. I didn't tell you, but this is exactly what we did with all the other examples. We were asked to find the area under this graph. Well, we subtracted 0. What 0? We subtracted y equals 0. So this area under the graph is above minus below. But because the below is 0, I didn't even have to mention it. It was minus 0. But if we are not discussing the area under or calculating the under a graph, but the area enclosed between 2 graphs, it's the same thing. Above minus below. Above minus below. That's how we calculate the area enclosed between 2 graphs. And we have a time for one more. So let's choose any area you would like. So, for example, let's say for 12, between this point, x equals -5, and x equals -1, the area is calculated from above minus below. The area between -1 and +3 is determined from above minus below. So you can choose any function you want. And let's calculate the area that is shaded. Now the second part right here, which will be next Wednesday. From here, we have to do all the work. We have to graph them. We have to find points of intersection. We have to shade in the area on our own and then find the area. But here it's still easy. They're giving us all the information we need. So please choose one to work on. If not, I will. Okay, I'll choose 12. In 12, we have two areas. The first one is the integral, as you see, from x equals -5 to x equals -1, from above, which is in red, which is f, x to the third plus 3x squared minus 9x minus 12 minus below, which is 4x plus 3, but I have to subtract 4x and subtract 3 dx, plus the second portion is between -1 and 3, the integral from -1 and 3, from above, that this time is 4x plus 3, minus below, which is f of x, minus x to the third minus 3x squared plus 9x and plus 12 dx. So again, between -5 and 1, this was above and this was below. Between -1 and 3, this was above and this was below. I calculate the two areas and add them up. And what will that represent? The orange area that you see here. This piece plus this piece. So let's calculate. I can simplify a little bit. So these two become -13x, -13x, and -15. That's the most I can do. Okay, so then we have x to the fourth over 4 plus 3x to the third over 3 minus 13x squared over 2 and minus 15x from -5 to -1 plus. Again, here I can simplify a little bit. I have 13x and I have positive 15. So 13x squared over 2 plus 15x minus x to the fourth over 4, not plus, sorry, minus 3x to the third over 3, and this time from -1 to 3. Where's my whiteout? Okay. So I can only simplify these. I'm going to plug them in. -1, so 1/4 minus 1 minus 13 halves plus 15. Now I plug in -5 with minus in front. 625 over 4 minus 125 minus 13 times 25 over 2 and plus 75. And all this is just the first one. Terrible. Not even Will can make me do this by hand. I'm kidding. Okay, so 13 times 9 over 2 plus 45 minus 81 over 4 minus 27 minus, you'll find me here Wednesday night still calculating these. I'm kidding again. Okay, minus 13 halves minus 15 minus 1/4 plus 1, etc. Terrible. Okay, so all this is the area shaded in. I already went over 1 minute, so I will not be able to do that. I will for next time. I'll calculate it. But thank you.